This is example 2 in our functions and graph topic. I had a look in example 1 at inverse functions, so watch that if you haven't already done so. We want to find the algebraic inverse of the function f of x equals a half e to the power x plus 1, and we're going to state a suitable domain and range. So what I was saying in the last video was that if you've got a function and we're going to substitute it for y instead of f of x, a half e to the power x plus 1, then we can say that the inverse can be generated by swapping the x and y values here. We're going to get x equals a half e to the power y plus 1. We're basically saying we want to reverse the roles of the x and y to get back to the starting point. So we swap x and y, and then we're going to rearrange for y. A wee bit trickier than the first example because our y is part of an exponent here. But we can use some basic algebra to get through. We want to multiply both sides by 2 in order to get rid of that half. So we could say 2x is equal to e to the power y plus 1. And we're talking about inverse functions, so we want to undo this exponential function, and the inverse of an exponential function is a natural log function. So we're going to basically take the natural log of both sides, in which case we end up with the natural log of 2x is equal to the natural log of e to the y plus 1. And of course these cancel each other out, and so we get the natural log of 2x is equal to y plus 1. And therefore if we take 1 away from both sides, we end up with y equals the natural log of 2x minus 1. And we can rewrite, because we introduced the y, or I introduced the y to help me, we're looking for the inverse function of f of x, which will be denoted by the inverse of x, is therefore the natural log of 2x minus 1. And that's my answer. I could check by substituting that back into here in the original function and seeing if it all cancels down to x, which it does. If I want to state a suitable domain and range, well, let's have a look at what that might be. The domain of the natural log of 2x minus 1, are there any values which we can't put in? Well, if you think about the idea of the what a natural log function looks like, hopefully you're familiar with the idea that the natural log function looks a bit like that. It's not very good. We know that we effectively can't get negative values for x. Okay, it gets closer and closer to 0. It can't be 0, and it can't be less than 0. So for a natural log function, okay, our normal domain will be x is greater or equal to 0. So that's a good kind of fact to keep in your head. So obviously if it's double that, it's the same idea. So and minus 1 here, though, that's interesting. So basically we can't put in values of x that are greater than 0. Okay, so in fact that has to be x can only be 0. It can only be positive. It can't even be 0. Which means that's actually wrong as well, isn't it? Let's update that. It must be positive. So I don't want to give you wrong information. So the domain of a natural log function is x is greater than 0, and that still remains here. So we can say that x is a real number and x has to be greater than 0, or we could say that x is r with a wee plus, a positive real number. Okay, what about the range? Well, let's have a look at all the possible output values. We've basically said that this is going to have a minimum value of, well, the domain's got to be 0, bigger than 0, but the output values go from effectively negative infinity upwards. So there's no range, and although this kind of slows down, it technically never stops. It doesn't stop rising. So we can't say that there's a limit to the y coordinates here, so we just have to say that I'm going to say that the inverse function here is just going to have to be from the set of real numbers. We don't have a maximum or minimum in all of that. And as I kind of noted before, what you should also be able to do is flip these around and check and see is the domain of the original function would also then be a set of real numbers, and the range would be x is greater or equal to 0. And if you were to check the graph of the function a half e to the x plus 1, you would find, of course, that that's true, because we know that an exponential function only has positive y values, so therefore the range in that case, the y values, is limited to values of x greater than 0. Okay, I hope that's been helpful. There's one more inverse example in example 3.